Okay, Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we will continue our lecture on chapter 2. Okay, alright. So let me share the slide first. Alright, so yeah. Alright, so this is slides for chapter 2. So we will continue from previous lecture. So today we will learn on 2.3. Right, so let me show you the slides for chapter 2.3, which is on the water activity and also the microbial spoilage. So as you remember, last class we mentioned on the what is a water activity, right? What is a water content and what is the relation between water activity and also water content, right? So also we learn about the free water and also bad water and what are the relation between water activity and also free water. So I hope that every one of you already understood and also already know what are the difference between water content and also water activity. And the most important that you need to remember is the thing that make the food spoil is because of the water activity. And the water activity basically, okay, it's a thing that needed by the microbial or by the microorganisms for them to grow. So that's why the water activity must be related to the microbes or microorganisms. All right. So today we will learn on water activity and microbial spoilage. So it's actually, as we know, water is often the major constituent in foods. We already know that 70% mostly, okay, foods contain water. Okay, so even relatively dry food like bread and cheese usually contain more than 35% water. So the state of water in food can be most usefully described in terms of water activity. So this is very important for us to remember that, okay, it's actually in food it contains water, and most of the food is 70%. Even the dry food also we consider as quite high, all right, which is more than 20%, which is normally 35%. So in terms of the states of water in food, so we call or we usually term it as a water activity. So as we learned before, so water activity can be measured, okay, in a scale, so from 0 to 1. So basically water activity scale extend from 0, which is dry, to 1, which is we call it as a pure water. But most foods have a water activity in the range of 0.2 for a very dry foods to 0.99 for moist fresh foods. Means that the foods which has a more moist um, okay, moisture foods, okay, is actually have a high value for the water activity. But for the dry foods, normally it has a scale, okay, nearest to 0. All right, so you need to remember that the scale for the water activity or the measurement unit measurement for water activity is a scale from 0 to 1, and 1 is the moist fresh foods, and the 0, which is approach or near to 0, means that it's a very dry foods. So this is a very general rules. So based on the regulation, if a food has a water activity value of 0.85 or below, it is generally considered as non-hazardous. So yeah, so it is very important for us also to remind that the foods which have water activity below than 0.85, so we can consider it as non-hazardous. But more than 0.85, 0.9 and above, we consider is as a hazardous food. Okay, this is because below a water activity of 0.91, okay, most bacteria, including the pathogens such as Clostridium botulinum, cannot grow. Okay, so most of the we know that the most pathogenic bacteria in the foods is actually Clostridium botulinum, and it can suffer, okay, in the condition which water activity is more than 0.9. So we try to avoid the foods from have a water activity more than 0.91. That's why most of the foods which are quite moist, we try to remove the water content during using a different technique such as dehydration, right? Such as what else? Drying, in order to make sure that the water content of these foods are below than 0.85. Alright, but exceptions for Staphylococcus aureus, which can be inhibited by water activity value of 0.91 under anaerobic conditions, but under aerobic condition, it is requires a minimum water activity value of 0.86. So, as we mentioned previously, so the water activity which is related to the microorganisms is depends on the types of the microbes itself. For example, Clostridium botulinum is very effective, for the food which has a water activity more than 0.9, whereas for Staphylococcus, it can be work in two different conditions, either anaerobic or aerobic. For anaerobic, it is can inhibit a water value at 0.9, but for the aerobic condition with the help of the oxygens, so it need water activity is of 0.86. Means that if you look at the food is not so moist, not so moist because it has 0.86, but that food can be contaminated or can be spoiled by the Staphylococcus aureus if it can put under aerobic conditions. So different microorganisms react with difference of water activity. In general, water activity requirement of microorganisms decrease in the following order: bacteria, yeast, and mold. So bacteria is actually need more water activity, but the yeast and mold normally need less than water activity to grow. Most molds and yeast can grow at minimum water activity of value 0.8. Thus, a dry food like bread is generally spoiled by molds and not bacteria. That's why when you look at bread, for example, again, after a few days you put in at room temperature, you can see the yeast or molds, on the bread. So because it can easily spoil, because that type of food bread have normally the water activity of 0.8, and below 0.6 no more microbial growth is possible. Thus the dried foods like milk powder, cookies, biscuits are more shelf stable and safe as compared to moist or semi moist foods. Water acts as essential solvent that is needed for most biochemical reactions by the microorganisms. So we need to remember that water is like the very important thing for the microorganisms to the biochemical reaction, so that make the spoilage of that types of foods. Alright, so this is the table showing the comparisons of growth requirement for the bacteria, yeast, and also mold. So you can see with the pH range, the water activity here, and also does it requires oxygen. So for the bacteria, for example, the water activity must be more than 0.85 so that it can be spoiled. So normally, is it requires oxygen? Some, beberapa lah, a few. So it varies, depends on the type of the microorganisms. So for the yeast, water activity more than 0.6, and the same for the molds also, which has more than 0.6, and then for the molds it requires the oxygen. So this is the pH range, for the bacteria and also the conditions of the food that need so that the microbes can have or can do their activity or chemical reactions, biochemical reactions there. Alright, so this is the graph showing the interactions between the water activity and also the microbial growth. As you can see from here, I like you to see this line: mold growth, yeast growth, and also the bacterial growth. As you see, at the x line here, you can see that the water activity, for the mold, it's here 0.7, yeast 0.8, and for the bacteria 0.85. So mostly the bacteria will grow at the water activity more than 0.7 or at 0.7 and above. Alright, so most bacteria cannot grow below 0.85. Okay, 0.85 most bacteria. Okay, so this, yes, just bacteria. So bacteria is here, right? But for the yeast and mold cannot grow below 0.65. Yes, yeast here, and mold is the same starting here. But it quite the graph is show that the mold growth, okay, is more steeper or higher than the yeast growth. Alright, but the starting here is same 0.65. Okay, so this is the relation between water activity and also the microbial curve. So if you like, if you see here, it also shows the hypothetical curve when showing effect of water activity reductions. Okay, you can see here. Sorry, this is the control. Sorry, yeah. Means that the water is not removed. Sorry, by the process. So but when we do the some process, for example dehydration, in order to remove the water activity, so we can see that the graph will be down, or will be showing the smaller, or I mean the lower as compared to the control graph, right? So this is shows this graph shows the importance of doing the process of dehydration or removing the water in order to reduce the water activity. All right, so all right, this is the water activity chart. Okay, so you can test yourself. So which from this water activity chart, all these microbes or bacteria or mold or yeast are located with. Okay, so this is the answer. We can see most bacteria, it must be 0.85 above. All right, and you must be remember that mold and yeast must be 0.65. Okay, and if you look here, okay, all the microbes here, it must be stated state at 0.65 here. Okay, so know the bacteria at this site. Okay, right. So the factors that affect water activity requirements of microorganisms is kind of solute added. If you still remember, the solute can be as your sugar, salt, or spices. All right, and then nutritive value of culture medium. Okay, nutritive value of culture medium, oxygen supply. All right, either the bacteria is aerobic, so it needs oxygen, temperature, and also the inhibitors or pH. This is the factors that affect water activity requirements of the microorganism. Means that in order for microbes, okay, to do or to make a biochemical reactions, they also needs these factors, okay, to ensure that they can make the food some reactions. Okay. All right, so if you see, for example, from this picture about the pH, okay, when we look here, lower pH, less bacteria because the acidic conditions, right? So that's why the food, the conditions of the food itself is plays an important role. For example, the food which high acidic means that it has a lower pH, so with a low